Okay, we're going to talk about experiment number 6 now. This is LC circuits and parallel resonance. So here's the circuit on a little proto board. You can see the input signal comes in here, goes into a 47 ohm resistor, and on this side we've got an inductor and a capacitor. Those two devices both have reactance to AC signals. However, there's one frequency where the reactance will cancel out. And of course, it turns out the reactance to the capacitor and inductor are 180 degrees out of phase. So when they do cancel out, actually the parallel combination of the coil and capacitor will look like an open circuit or an infinite circuit. So I've got the scope set up, and I'll take and move my camera over there in a second. Here's the signal generator as always. So I'll move over and let's see if we can get a good picture here on the scope. Well, we want to get the focus correct, and let's see, it's not showing all of the screen. Basically now we have all of the screen, and I'll go and set the frequency for the first measurement. So you're going to take and fill out the chart that you have for the experiment, and unfortunately you see a reflection of me pretty well in that. No. Let's see if I can. I can't move over. I'll get behind the camera as much as I can. I don't know how easy it is to see whether you have a yellow and a green signal. The yellow signal is the input, and the green signal is the output. I'll try one more thing here. I'm going to try to shut the lights off, maybe. Reflection's even worse. So. Okay, so I'm at a frequency of 10 kilohertz. So our first measurement is the input, and the input peak to peak, channel 1, that is the yellow one, 9.9 volts. The output is 147 millivolts. I've got a phase angle over there, but you're not going to measure that or record that in this experiment. We will talk about when the phase angle goes to 0, what frequency that is, and it'll be the resonant frequency, but for the time being, just ignore that phase measurement. So I'll go to the next measurement, which is at 20 kilohertz. I'll adjust my scope a little bit here, and we notice that the input peak-to-peak amplitude is looks like 9.8 volts, and I get 263 millivolts coming out. Let's go to 40 kilohertz. I've got to adjust the scope readings here a little bit. At 40 kilohertz, it's jumping around, 9.8 volts going in, 540 millivolts going out. We go up to 60 hertz. At 60 hertz, 9.9 volts going in and 810 millivolts coming out. So I'm going to have to constantly be adjusting the scope controls here. At 80 kilohertz, now we have 9.9 volts going in and 1.26 volts going out. Move it up to 100 kilohertz. At 100 kilohertz, I have to adjust the scope because the output's gotten larger here. So at 100 kilohertz, it says 10.1 volts going in and just about 2.01 volts coming out. Now we're going to take and make smaller steps. At 120 kilohertz, we have 10.5 volts going in and 3.36 volts coming out. The next measurement's at 140 kilohertz. At 140, I've got to take and adjust the scope controls again. At 140, we have 12.8, we'll say, volts going in and 7.2 volts coming out. Let's go to 160. At 160, it's still on the scale, 14.6 volts going in, 9.7 volts going out. And an interesting thing, if we'll take a look to see the phase angle on the scope, is plus 10 degrees roughly. If I went back to 140, it was minus 30 degrees. So something's happened between 140 and 160 kilohertz. So we already got this one. Let's go to 180 kilohertz. At 180 kilohertz, 12 volts going in, 6.4 volts going out. So the output's starting to drop. So let's go to 200. If I go to 200 kilohertz, hit the stop button now. 10.9 volts going in, 4.4 volts coming out. Now I'm going to jump up to 400 kilohertz. I'll hit the run button again. At 400 kilohertz, notice all of a sudden the green one's kind of really gone down. I got to turn the gain up. I'd been turning it down all this time. Now we have 9.7 volts going in and 1.02 volts going out. That's at 400 kilohertz. We'll go to 600 kilohertz. Run the scope. I can change the time base a little bit. 9.7 volts going in, 610 millivolts coming out. Two more measurements. We'll go to 800 kilohertz. At 800 kilohertz, we'll stop at 9.7 going in, 430 millivolts coming out. And our last, is that our last measurement? No, we're going to go all the way up to actually to 10 megahertz. So at 1 megahertz, it turns out we have 9.7 volts going in, 350 millivolts going out. I'll take the next measurement. It's going to go to 2 megahertz. At 2 megahertz, I've got 9.9 volts going in, 150 millivolts coming out. So I'll turn up the gain here and change my time base again. So let's go to 4 megahertz. At 4 megahertz, 10.1 volts going in, 68. Bounce around. Let's just say 68 millivolts coming out. Let's go to 6 megahertz. 10.5 volts going in, about 105 millivolts coming out. Did that go up? Let's go back to 4. Yeah, for some reason here all of a sudden the output's going up, and that's an interesting effect. Probably something to do with the capacitor and inductor, how they're constructed. And now it turns out that they're no longer purely, we're up to 6 megahertz, no longer purely just inductive or capacitive. Let's see if we got any more here. At 8 volts, so it's gone back to 163 millivolts at 11 volts going in, and finally at 10 megahertz, 11.4 volts coming out at 220 millivolts. So probably what I would say to do is neglect the measurements. Let's see where they started going back up. They were going down till 4 megahertz, so neglect the measurements above 4 megahertz. There's only 3 of them, so let's just go from up to 4 megahertz as our last measurement. Okay, that's it for this video, and I'm going to post this on Blackboard for you.